morning. Hello everyone. This session will be on progressive wave for JEE Main. I am interested to discuss the past year's questions, whatever I have collected from internet with you. Differentiation questions were asked mostly on progressive wave, standing wave, wave equation obviously, and bits. There is no question on Doppler effect as it is not included in syllabus, it was not expected also. So Doppler effect not in JEE Main syllabus. Will not find even one question analyzed on it. Intensity of progressive wave question is there because you cannot avoid the concept of intensity in case of wave, as it is a very important topic for wave preparation. It is equally important in class 12 wave optics also. I hope you remember the formula required for the transverse wave, intensity of transverse wave, the stationary wave, Newton's formula in waves, and stationary wave in strings and stationary wave in closed pipe and open pipe. I will definitely remind you whatever formula required. The first question I have selected this one, it came in 31st Jan shift 1 2024. That fundamental frequency of closed organ pipe is equal to first overtone frequency of an open organ pipe. For a closed organ pipe, you know, not required this arrow one. Closed means one end is closed, the other end is open. The fundamental frequency N0 is equal to V by 4L. Whereas in an open pipe where both ends are open, the fundamental frequency is given by N0 equal to V by 12. For same length, frequency of this is double that of the closed pipe. And here for pth overtone, Np equal to 2p plus 1 N0. Remember this? And for this one, Np dash will be p plus 1 N0. This is what for pth overtone. This is what for pth overtone. So open pipe consists of all the harmonics. But here only odd harmonics are there, and that's why you know sound is not so musical in closed pipe in compared to the open pipe. Fundamental frequency of closed organ pipe is this thing. First overtone frequency of an open organ pipe, so you have to put P equal to 1 over there. So what is given over there that you write? Given pipe length is different. Okay? The fundamental frequency is V by 4L. Pipe length is different, I told you. This is equal to first overtone of this. First overtone means 2 N0. N0 is V by 2L. You take L2. What L1 stands for? Length of closed pipe, and L2 is a length of open pipe. Okay? So this thing is given, and you have performed the experiment in air, so V will remain the same. Cancel V out. So it is going to be, I have to find the length of closed pipe, means L1. L1 from this relation is L2 by 2. L2 is how much? L2 they have given. L2 by 4, sorry, not 2. L2 is given. How much? This is 60 centimeter by 4. That is 15 centimeter. This option is correct. Okay? So closed pipe, open pipe, formula revised and one sum is done. Let's see next question. This question will be on the wave in bounded medium, that is Newton's formula. From Newton's formula, if I just tell you, V equal to, with the corrected one you have to write always, gamma P by rho. Main formula is V equal to under root E by rho. E is the elasticity, rho is the density of medium. And in case of air, E can be replaced by gamma into P. Gamma is the ratio of two specific gates and P is the pressure. Or you can write, since PV equal to nRT, for one mole you write better. Therefore, PV, this P we can replace by RT by V. So V is going to be gamma RT by V into rho. This is gamma RT, V into rho, this you have taken for 1 mole, no? PV equal to RT means for 1 mole. So this gamma RT remains the same and V into rho will be what? This is mass. Isn't it? So what will be the velocity in air that we are going to find? R is given 8.31, gamma is 1.4. Gamma is what? 1.4. They told you to take 1.4 only. (8.31) and T is what? Absolute temperature, that is 273 divided by M. What is mass here? Mass of oxygen molecule? Gram. Everything is in CGS, SI, and this one CGS, not possible. So 32 into the power minus. Alright? Just find its value using your calculator or whatever right now at this moment and check whether it is coming 314 approximate 14 point you can write 314 meter per second. Is there no option? No. Then what to take? 314 or 314 what? Actually this option might be I have copied wrong. This will be 315 meter per second. Okay, not 325. So it is approximately 315 meter per second. Okay? This is velocity of sound. Go for next one. This is on progressive wave. Check the question. Just check. Not a difficult one at all. Frequency of the wave you have to find. With what equation you are going to compare? You know wave equation. So here, to find the frequency, we need to compare it with the standard equation of the wave. I just remind you, the equation of wave is y equal to is sine omega t minus kx, where A equal to omega is what? Coefficient of t. Omega is 2 pi f. Okay? So if we rewrite this equation, it will be y equal to 2 cos just put it here, 2 into 330 is 60 pi into t, isn't it? Minus 2 pi. 2 pi into x is coming. Why? 2 pi x is there, but how to compare then these two? What omega stands for? Omega 2 pi f, that is what? 660 hertz. So f equal to 660, no, 660 pi t, pi. So f will be what? This divided by 2 pi. That is 600. So this one is, this frequency is 330 hertz. Clear? Next time you start vibrating with different frequency, I will find a question like that. Let us go through number 4 first. Let's go through this. I will explain. Point source is emitting sound wave of power this much at the origin. This is a simple question. Intensity obeys inverse square law. Intensity obeys inverse square law. So at a place, intensity proportional to 1 by r square, or I equal to what? K by r square. Okay. Now point source is here. This one 2 meter radius. Four meter. So I1 will be K by 2 square, K by 4. And I2 will be what? K by 4 square, K by 16. Alright? Therefore, they are to find ratio of intensity at 2 points located at 2 meters. 2 meters come first. So we find I1 by I2. We find I1 by I2. What is I1? I1 is simple, K by 4, and this is K by 16. So this will be, 16 by 4 is equal to 4. Okay? So this one is a very simple problem if you know the concept. Go for next one. In a closed organ pipe, the frequency of fundamental note is 30 Hz. It means what? Just we have seen. So first some length was there. Closed organ pipe. Fundamental note frequency, suppose the length be, this is closed one. Closed pipe. Area of cross section given 2 centimeters square. Initially no water was there. Length be L. So injury is there, V by 4L. Frequency of fundamental tone, they have given note, but the correct statement is tone. Tone means one frequency, that is 30 Hz. So this is number 1. When certain amount of water is poured, the length reduced. Okay? Now, certain amount of water now poured, fundamental frequency increased to 110. So length is changed. That's why it changed. Okay? Initially 30, now it is 110. And it will be V by 2L dust. V by 4L dust. They have given that only, no? Fundamental frequency increased to 110 Hz. So I like this. Now you have to find how much water was poured if area of cross section two into the power 4 minus 4 meters square. This is area of cross section. Now, if you can find L in dust and then multiply the difference by area of cross section, you can easily get how much volume of water has to be poured, isn't it? So find L from there first. V by 30 into 4, isn't it? So this is V is what? 330. That divided by 30 into 4. That is 11 by 4. Is the length in the first case. Second case length how much? V by 110. That is 110 V by 4L, no, sorry. It will be 4L. So it will be 3/4. 3/4 of what? You assume that 3/4 of, because the way you have taken, it must be in meter. Meter. So length in tube length is how much? Therefore, the length increased, length of the tube decreased. L minus L dash. 11 by 4 minus 2. Length reduced by this much. So volume of water poured into this part only. Am I correct? Check once. Oh, not 2. This is 3 by 4. Sorry. This is 2 meters. Okay? Now, area of cross section is given 2 centimeters square. You can write 200 also, no problem. If you want to keep in 100. 200 centimeters. Therefore, required amount of water is equal to 200 into 2 centimeters square. No, multiplying volume by height, it will be centimeter cube. So 400 cubic centimeter. Clear? Let us go for next one. Just read the question, I'll do it. Closed organ pipe 150 centimeter long gives 7 beats per second with an open organ pipe of length 350 centimeter. Both vibrating in fundamental mode. The velocity of sound is how much? Try once. Can you do it? Closed organ pipe 150 meter long, 150 centimeter long. For open pipe 350 meter per second. Both vibrating in fundamental mode. The velocity of sound is what? 7 beats. So find N0 equal to V by 4L here. So this one is V by V is how much? V have to given? No, that we have to find. V by 600 Hertz. What about this thing? Is N0 dashed V by L dash to we have to find it is no L dash 350 given. We cannot change it. Closed organ pipe. Oh, no, open pipe this is. So for open pipe V by 700. Okay. Now this one larger. N0 greater than N0 dashed. Okay. Now what is given over there? N0 minus N0 dashed. This is bit frequency or just change in frequency, difference in frequency. This is V by so 100 V divided by alright. So this to get cancelled. V by 4200. Okay? V by 4200. Now this is 7 given. given 4200, you make it meter. 4200 equal to, this is centimeter, this is equal to how much? 7. 7 into 42, so you just put the value over there, 4200. So it is 294 meter per second. Clear? Understood? Go for next problem. I found these questions only what I am discussing with you in 2024 paper. That's why I have started doing that. This tuning fork resonates with a sonometer wire of length 1 meter, stretched with a tension of 6 Newton. Tension in the wire changes to 54 Newton. Same tuning fork produces 12 beats per second with it. Then the frequency of the tuning fork will be what? Length of sonometer wire given. You know the formula for frequency of fundamental tone in sonometer wire? 1 by 12 root T by mu. Isn't it? Understood? Length remains the same, only tension is changing. So N0 minus N0 dash will be, initially how much was there? 6 by mu. This one is larger, no? Next one. So we have to keep a space over there. 2L dash root over 54 by mu. This they have given 12. The difference given 12. As this one going to be larger because L remains the same. We cannot change it. So N0 dash must be larger than N0. As so, what does this imply? N0 dash minus N0. Okay? Equal to 12. Now put the values over there. N0 dash. N0 dash is this one. 1 by 12 minus 1 by 12 6 by mu equal to 12. They have asked you to find the initial frequency. This value they have asked you to find. We don't have to bring the instrument they are talking about. Just this is enough. Take root 6 by mu common. So 9. Root 9 means 3 minus 1 equal to 12. This is equal to 12 by 2, no? Just check. I have taken root 6 by mu common. 1 by 12 root 6 by mu we have to find. How much is this? 12 by 2, not 6. So this is equal to 6 hertz. This is the starting one, no? 1 by 12 root 6 pi is starting one. So that value is 6 hertz. Go for next one. Sonometer wire of resonating length 90 cm has fundamental frequency 400 Hz when kept under some tension. Resonating length of the wire. See, questions are coming from these two topics mainly. Standing wave in pipes, standing wave in strings. Okay. Sonometer wire has length 90 cm and fundamental frequency 400 Hz. When kept under some tension, fundamental frequency of sonometer wire is what? Just we have done 1 by 12 root over 3 by mu. This is equal to, they have given 400 Hz. Okay. Now to get 600 Hz, to get more, we need to reduce L. Let L is reduced to L dashed. So 1 by 2 L dashed root 3 by mu. This is equal to what? 600 Hz. They have given that. This L dash you are going to find. Just divide number 1, number 2, because this length is given 90 centimeters. So just divide dividing 1 by 2. 1 by 2 we have L dash by L. C by 2. Okay? So L dash will be what? L dash or L? Wait a minute, which one required? "90 centimeter has with 600 L dash will be coming. Dividing 1 by 4, 400 by 600. 2 by 3. So L dash will be L into 2 by 3. This is L is what? Just put the value over there, 90 into 2 by 3. This is 60 centimeters. Okay? Go through next question. Two open organ pipes of length 60 and 90 centimeters resonate at 6th and 5th harmonics respectively. The difference of frequencies for the given mode. Very simple question. Not difficult at all. Okay? So this I remind you, this is for open organ pipe and these are harmonics, not overtones. For overtone, entry will be P plus 1 N0. For harmonics, entry will be P N0. Clear? And fundamental frequency is V by 12. Clear? So change of frequency delta F. This is going to be 6 V by 12 minus what? 90 centimeters even. How much? 5th. 5V by 2L dash. Just substitute the value. 333, this divided by 2 into L. L is how much? L is 0.6. 5 into V by 2L dash. Alright? So you take this minus this 90, you write 0.9 meters. I have changed here. 60 I have changed 0.6. So there will be 333 if I take common. 6 by 1.2, 5 by 1.8. This is 50 by, do it my way, you need not share, you can do it yourself. Okay? So take the LCM, that is 120, 36 is the LCM, so 2 minus 100. No, it will be 3 into 60, 180. Minus 100. Okay? I got this. 180 minus 100. So 218, 240. Now check how much is coming. Sure, C gets cancelled here also, isn't it? 116. But I am not getting an integer, some mistake is done. 6 into 333 by 2 into 1.2, 5 into 333 by 2 into 0.9. So 6 by 1.2, 5 by 60 by 12, 50 by 18. See 180, oh, 36 LCM, so 180 minus 100, 80 is coming. Oh, once more it gets cancelled. I thought it is not coming, but it's come. Okay? It is 740 hertz. Clear? Go for next one. Closed and open organ pipe have same length. Ratio of frequencies of their seventh overtone. You need to remember that expression for create overtone in a closed pipe and create overtone in an open pipe. Two B plus 1 N0 for create overtone. For open pipe, NP dash will be equal to P plus 1 N0. Here N0 is what? V by 4L, here N0 dash is what? For close by V by 2L. Isn't it? They have given 7th overtone ratio of the frequency of their 7th overtone. So here 2 into 7 plus 1, 15 in 0, and here in 7 dash will be 8 in 0 dash. In 0 is what? It is V by 4L. So you can quote, you can calculate. 8 into V by 2. Now, here, ratio of the frequency, close first. This we have to find, N7 by N7 dash. Two by 8. So this will be it just confusing. A minus 1 by A. So you put that only, then find the value of A. A minus 1 whole divided by A. So 1 by A will be one by 16. So A equal to 16. See, these wave function JEE direct formula based. And the questions we have solved from collected from last year's two differentiations based on closed pipe, open pipe, the way I told you in the beginning, and vibration of stretched wave, equation of progressive wave, which we got in one case, but not direct problem from this. Okay? I hope you have understood. Thank you.